The screen is visible, right?
Yes, your screen is visible. But we are not able to hear Thoralf.
Yeah, I think Thoralf needs to unmute himself.
Thoralf, could you try to unmute yourself?
Is he there? Is he facing some technical problem?
Thoralf, you can write in a chat. We can see the chat
Yeah,
also.
we can see the chat if he has a problem. So I just got to know that he is there on the call, but he has not yet connected his audio.
Mm-hmm.
So he needs to connect the audio.
Hello, I guess it's just connected as audio. Yeah, I think we can hear it.
Yes, now we can hear you. We are dot at
Naman, can you hear me?
Yeah, we can hear you, Thoralf, loud and clear.
Okay, we are good to go.
Okay, I think now I can hear you as well.
Okay.
Naman, could you check your audio as well?
Yeah. Just a minute. Maybe I'll turn.
The one thing I don't have yet, I cannot click the share button yet. I presume somebody has to do something.
Yes, Thoralf, I'll make you a presenter when you're sharing. Thoralf, was I audible to you?
Yes, sorry, yeah.
Yeah, I'll make you a presenter.
Okay, good.
Okay, Subhash, get started.
So good morning and good afternoon to everyone, and welcome to today's session. So welcome to Oran Xapp developer session. So this is a joint session by Samsung and Nokia. Sorry for interruption, miss. I'm not able to control the slides. Just give me a moment. So today we have our 3 speakers. So let's quickly run through the introduction of us. So our first speaker is Thoralf Zicki from Nokia. He is an expert in telco platform with over 20 years of experience in building the complex real-time system. Recently, he has been key contributor in RIC architecture work, and he is a PTL of the near real-time RIC open source project in Oran SC. Our second speaker is Subhash Kumar Singh from Samsung, myself. So I have been contributing to many open source that comes under LFN, and I hold committer role in RIC platform and RIC app project. Apart from Oran SC, I have significant role in ONAP, ODL, OpenO, and ONF projects. Our third speaker is Naman Gupta from Samsung, and he has been contributing to RIC app framework and Hello World app of Oran SC. He holds committer role in RIC platform and RIC app project. He has also worked on the ONAP and non-RT project. So in today's talk, Thoralf will take us through the introduction of Oran Alliance and the Oran software community. Then in second part of the presentation, I'll take you through a concept of Xapp and how you can develop the Xapp using the Xapp framework. Then Naman will take us through the demo to represent the concept of Xapp. And finally, we will have our question answering session. And yeah, feel free to write your question and answers in the chat window. Finally, we will answer it. So yeah, this is all about the today's agenda. And now I would like Thoral to take us through the overview of ORAN Alliance and OSC. So over to you, Thoral. Thoral, could you try to
Thanks.
share your
Thanks.
screen?
Can't do yet. Don't have the share button enabled. Now I have. This one. Here, you should see a shared screen right now, correct?
Yes, I can see.
Okay. So let's start. Hello and good afternoon. I have the honor of starting the session with a short overview of the ORAN software community project and how it relates to the specification work of the ORAN Alliance. I would like again thank Supash and Naman for inviting me to do this session together with them. They will present later how to develop so-called Xapps and do a demo of their work. My name is Thoral Cihi. I'm the PTL project technical lead of the near real-time wake platform, which is one sub-project within the ORAN SC project. And it is a platform on which those Xapp microservices are being run. Okay, let's start with the ORAN Alliance. There are actually many activities happening that are labeled open run. So it's a buzzword currently. But maybe the ORAN Alliance has been the most successful of them. It's a standardization body, not much different from the ones that make up FreeGBP. And in fact, it reuses many of the specifications of the FreeGBP specifications. It focuses, or its goals wants to promote run openness. So this is about intercompatibility of specifications of the implementations. It wants to promote hardware and software separation. So this is about virtualization and then maximizing the use of common off-the-shelf hardware. And then a big aspect is as well the programmability. So this is about APIs and extensibility of the run of the radio access network. And in this, the ORAN Alliance also has as a goal to explore open source wherever appropriate. Some fun facts about the ORAN Alliance you see here. So it was launched in June 2018. What's that, about 3 years ago? It has by now about 250 or more contributors. The ORAN Alliance makes a slight distinction in legal terms between company contributors or academic contributors on one hand side, and then on the other side, mobile operators. Of those, there are 28 that have joined the Open RAN Alliance. The founding members you see here, 5 of them. And maybe that's it about this very high level. The ORAN Alliance then works with has 9 working groups, key working groups, and a couple of other organizational or working groups associated with this. These are the 9. I don't go through all of them, maybe highlighting only working group 1, which is defining the overall architecture of the ORAN, of an ORAN network and use cases. Then we have number 2 and 3, working group 2 and 3. They focus on the non-real-time wake and the near real-time wake. The non-real-time wake focuses here on the A1 protocol and then talks via this A1 to the near real-time wake, which then talks E2 southbound to the other run elements like a GNOD BC or DU. Some other specifications that I worked on are on the open front hall side. ORAN clearly favors this EC3 7.2x split defined by FreeGBP. Then on the working group 5, it's about intercompatibility profiles for these interfaces on the run side, F1, W1, and so on. And then the working group 6 focuses on cloudification and orchestration. And here the interface is called O1, which is the FCAPS, fault management, configuration management, and so on in a run element in a run network. And then it also has a lifecycle management interface, the O2 interface, which is about deploying virtual network functions, but also about deploying the Xapps of the near real-time wake. If we move on, so that was the ORAN Alliance. Then on the other side, you have the ORAN software community. So this is the implementation of this mission statement of the ORAN Alliance to engage in open source or explore open source implementations. The ORAN software community was established in April 2019, about a year after the ORAN Alliance. It's a project, co-project by the ORAN Alliance and the Linux Foundation. What the Linux Foundation brings to the project and to many other open source projects is one, it's a legal framework, and it also provides a lot of open source project infrastructure. The goal of the project is to implement open source software aligned with the architecture specified by the ORAN Alliance. So I mentioned already legal and infrastructure services. So the legal framework is actually quite interesting. There is a concept of a series of projects, limited liability company. So this allows very quickly to create new separate divisions using the same legal limited liability company. And those separate divisions within that are called series of projects, LLC. And they allow within those divisions to have completely separate completely separate liabilities. And that's a good thing because you want to protect the project from the other projects as well. Infrastructure service, I have a slide later on that. So obviously as an open source project, you need CI and source code management and so on. In the ORAN software community, there are now about more than 20 companies contributing source code. 92, I checked that last week, 92% of the commits come by the top 10 contributing companies. And the license used in ORAN SC is the Apache license. So far, we have had 4 releases. There's a release every 6 months. You see them here, Amber, Bronze, Cherry, Dawn. Those are colors. The current release, we are just in the last steps of releasing that. So expect the press release next week or the week after for that one. And then we will continue only with numbers and skip the color coding. So the next release will be the e-release end of this year. Day to day, there is a technical oversight committee meetings every week on Wednesdays. And then within the ORAN software community, there are sub-projects. I will tell a bit about them in the next slide. They have their own meeting practices. For instance, we on the near real-time wake sub-project, we meet every second week on Tuesdays. The legal aspects are again interesting. There is a separate project that is very strongly linked to the ORAN SC, and that's the ORAN Specification Code Project, SCP. And it has a separate charter. It was created at the same time as the ORAN SC, and it delegates the administration of that project to the ORAN SC talk, so to the same talk that I talked about a minute ago. It shares the infrastructure and meetings with ORAN SC, but the key difference, it has a different license, and that's the ORAN software license. And for that, I have another slide later on. Let's move on. These are the sub-projects of the ORAN software community, and you see there is some mirroring of the working groups. So for instance, working group 3 is clearly mirrored in the near real-time wake platform. So there was a working group on the ORAN Alliance side. And the people working on the implementation here work very closely with the specification guys. Very closely with them. What else? So we have a project that develops Xapp. We work very closely with Beam Platform and Xapps, but it's a separate project. There are some projects that never took really off. One is the OCU and another one is the ORU. So here we have very little implementation on both of them. But an implementation that is very active is on the ODU side, where we have separated ODU high and ODU low, which are separate sub-projects, but they also work together. Other sub-projects worth mentioning are maybe the non-real-time rig here. They work on an A1 policy manager located on the SMO and the management layer side, and some other A1 related functionality. There's an OAM project up here that focuses on the O1 interface, on young models, and on O1 reference implementations. And maybe the simulator project is also quite important, at least for us, for the near real-time rig, because it provides an E2, the key interface or key protocol used in the near real-time rig platform, E2 simulator. A couple of others, maybe I don't go through them in detail now. Let's move on. Licensing, I talked about this. So we generally use the Apache license, but the SCP project uses this ORAN software license. Everything that is documented is under the Creative Commons license. The Apache license that we are using is a very liberal license. It includes an explicit patent license, and that makes it quite easy to use also the source code that you get from there. The ORAN software license is different. It's referred to SCP license, and especially on the patent side, it treats them differently, and you have to read to the license to be sure how it actually works. But it grants also patents, but for very limited, a patent right, but for very limited use cases or usage scenarios. We don't allow any contributions without a signed, online signed contributed license agreement. This is a service that Linux Foundation provides to us. So before you want to contribute, you have to actually sign this either as an individual contributor or as a contributor from a company. Minor detail, we also use the Asm1 compiler that was originally implemented many years back by Lev Volkan, an open source Asm1 compiler. Asm1 obviously being an important part in the implementations. That's under BSD 2 and 3. That's why we didn't actually work on this under ORNSC on those extensions. But they are, so if you start using Asm1 and you want to use an open source compiler, that's the one to use in this specific fork of the Asm1C. We make sure that it works with the ORAN Asm1 specifications. If we move on. So once you have been a contributor and have contributed a couple of things, or somehow in other ways kind of proven that you understand the source code, you can also become a committer. A committer's role is he's the primary contact for a component. Committers review code contributions, and they're also the only ones that can merge source code into the master or maintenance branches. And they're also the only ones that can release, that create those releases every 6 months, binary releases. We manage the committers in a file directly in the repository. That file is info YAML. There's an example here. And if there's a new committer, we simplified the process. Now it was more complex before that. It is a simple majority vote in the review tool in Gerrit. And the change, once committed, is then automatically also notified to the ORNSC TOC, so that everybody on the TOC knows what's going on. As I mentioned, LF provides legal, but also infrastructure services. Those are a couple of examples that we use. So there is Gerrit as a source code management and review tool. We need an image repository for containers. That's Nexus 3. We need binary artifacts, which are stored in Package Cloud. There's for license checks, we use Nexus IQ, static code checking, code coverage, Sonar Cloud. The documentation is automatically generated in Read the Docs. For testing, we use a lot the robot framework. On the unit test side, CQNG testlers, we are more liberal, so you pretty much can use anything you want. And more details are in this link. And I don't go through the details here either. So since I'm the PTL of the Near Real-Time Rig project, I took the liberty also to talk a bit about the near real-time RIC or run intelligent controller, near real-time RIC. So everything actually starts with the question on how do you do programmability in a resource-constrained environment? So the idea was of ORAN Alliance, add programmability into the run. The G0B, especially if it's implemented as a bare metal implementation, CUDU the same, their dimension tested with the traffic patterns that are defined by operators eventually. So now what you want for programmability, you need additional computing resources, you need additional memory. You can just add those. So one way obviously is to make the whole thing virtualized, and then you can deploy it in a cloud infrastructure and you use the cloud scaling resources to address this problem. The other solution is to add physical plug-in cards. So you have to send an engineer to plug in the card if you want programmability of the run. And seeing those alternatives, what then was decided on our Alliance side is actually to extract this programmability as a programmability platform, the near real-time run intelligent controller, and then also the non-real-time equivalent into a separate platform that typically is co-located or very closely located to the actual run or part of the run. And that's simply to address the problem that you have to still transfer a lot of data that you need to address this programmability over a new interface, the E2 interface between CUDU or G0B, E0B, and the near real-time RIC run intelligent controller. So this is an aspect of latency, but also of bandwidth that you have to reserve on this interface. But once you have this, you need a platform that manages this connection. A very early decision was that there's only one single E2 connection between a run element, an E2 node, and the near real-time RIC. That connection is managed by the RIC platform, which isn't in this picture, or the gray box basically. And then there are internal interfaces between the platform and Xapp microservices. Xapps are nothing else than microservices that run inside the run intelligent controller. And those Xapps then consume those interfaces and do manage specific functions of the run. So for instance, they can do radio resource management or optimization of that. They can do mobility optimization. They can do traffic steering. They can do slicing optimization and so on. And most of those services will use AI ML algorithms. So you very quickly need to think also about how you address computing resources for those with GPUs or other solutions. The other interfaces that you see here, there are the normal ORAN interfaces. So there's A1 northbound towards the real-time RIC located on the SMO side, then which also does run control, but it has higher latencies simply by being located not located within the run. There is much different data available. So typical data that you receive over O1, and also the data granularity is very different than what will be available here. O1 is the FCAPS interface, so that's to the management layer. Then we do have here the E2 interface, and then the F1 between CU and DU, and here the front roll interface between DU and remote radio head. Let me take a look at the time. So that's the near real-time RIC. I will still go to that slide. Let me check and this one, and then we go over to Supash and Naman, if that's fine for you. These are the basic procedures of the E2AP protocol. This is how Xapps eventually communicate with the run. Typically, there are two ways how to use it. One is, and all of them are reusing a concept of subscription. So you see here subscription, subscription, subscription. One way is on the right-hand side, where we have the rig doing an insert subscription, and this insert subscription eventually works so that on the run side, if a particular trigger condition hits, the call flow is suspended or halted, and an indication is sent to the rig. And that indication you see here up here, the rig does, the Xapp does detect the event, perform some action, and eventually sends a control event back to the run, and that control event tells the run to continue with the call processing, to interrupt it, or to modify its behavior accordingly. The other way how to use the E2 protocol is with report subscriptions, where the rig also tells the run, send me particular indications when you detect a particular trigger, but it continues with call processing. And then the rig will consume those reports. They are very high bandwidth, low latency reports, and then go to the run and modify the run behavior with so-called policy subscriptions. That works so that if the run detects a trigger, it performs the policy autonomously and then continues call processing. That's the basic principles of the E2 AP. There's more to it. Let's not go into the details there. I have one slide at the end that maybe if the material is available afterwards, you can take a look at. But we don't go through this, I think, today. Last slide I wanted to talk about, and then it goes to Subhash and Naman. This is the near real-time rig platform that we have implemented on open source side. Everything that's in yellow is basically part of this near real-time rig platform and the microservice deployed into Kubernetes or any other cloud infrastructure. These services that handle the E2 protocol are the E2 termination, E2 manager, and the E2 subscription manager here. Let me, oops. So this, and this. Then we have multiple components that handle the O&M aspects. So there's something about performance management or statistics, logging and tracing, and then about handling of alarms. Configuration we have up here. This is combined with the Xapp manager, a manager that when an Xapp is deployed handles the registration of the Xapps. Then we have the handling of the external interface, northbound interfaces. So that's the A1 and the O1. O1 is a netconf-based protocol. A1 is a REST-based JSON protocol. And then all the routing within the of the messages within the platform is taken care of by the routing manager together with a library that we call Rig Message Routing Library, RMR. And when you implement an Xapp, you reuse the Xapp framework with a couple of libraries that are available to you in these 3 languages. And then you see here a couple of example Xapps. They are deployed as a microservice using the O2 interface eventually, but basically right now they are deployed into the Kubernetes system. And then they register with the Rig platform. Maybe with that, I hand over to Subhash and Naman. I thank you already now for being interested in this topic. And I will, of course, remain in the WebEx meeting for the Q&A at the end. Okay, thank you.
Thank you, Thoralf. I'll pass on the presenter rights to Naman back. We do have a question for you, Thoralf, so I'll put it at the end.
Okay, it's in the chat, is it?
It's in the Q&A section.
Okay, I don't see that, but maybe we handle it at the end.
Okay, yes.
Yeah.
Naman, back
Is the
to you.
screen visible?
Yes.
Okay.
Okay, so thank you, Thoralf, for taking us through overview of ORAN SC, ORAN Alliance, and also introducing with Rig platform. So now now further in this session we will continue in Xapp development part. We will understand what exactly is the Xapp and how the framework can help us to develop the Xapp. So in order to understand the idea of Xapp, I would like to bring some analogy from Android world. So in Android world, you can see Android has abstracted the low level details and very minute details and abstracted one simplified API to the developers. So the any application developer can use these APIs and then can write the application very quickly. And similarly, we are trying to bring the idea of Xapp in the RAN world. So in the RAN world, ORAN Alliance is bringing bringing the specifications, new standards, so that they can bring innovation and openness in the RAN world. So here in this picture, in the right side, you can see RIC, that is a RAN intelligent controller sitting on the top of RU, DU, and CU. So RIC is now not only the RAN controller; it is something more than that. RIC actually is a platform which can host the application which is running some specific business logic and also running AI ML to fulfill some requirement. So that is the actually innovation we are trying to bring in. So any vendor who is not at all related to RIC, they can write their application and they can host on the RIC, and yeah, they can control the RAN. So yeah, so here we can see how exactly the RIC platform is designed. So in the yellow boxes, you can see there are multiple microservices are running, as explained by the Thoralf. Also, you can refer to those slides also. So that's all about the RIC platform. So it has various services like A1, O1, E2 Manager, E2 Terminator, everything. Those helps you to interact with various interfaces like O1, A1, and E2. And you can see in the blue boxes there are the Xapps which helps you to which actually running the business logic. For example, there's a traffic steering Xapp. So the idea of traffic steering Xapp is to let's say some UE has some degradation. So we would like to hand over the UE to certain cell which give the UE better performance. So this kind of idea you can write it. For example, KPI monitor. Actually, it will read the KPI parameters from the RAN and it will push us to the database. So this KPI related to the cell, it's related to the UE, and further some other Xapp can utilize this information and they can do some meaningful things. And then you can see the Hello World Xapp. That is actually one reference Xapp written in the RIC app open source of the ORAN SC to help the developers to understand how exactly they can write the application, and yeah, they can do the development. Now after understanding these concepts, let's go a little deeper and make our hand dirtier by understanding the framework, writing some coding stuff, and let's go through it. So so in the left side, you're seeing a layered key. Just in order to understand the idea of the framework, you can assume that it's a layered key. So that is actually the services and the APIs offered by offered by the RIC platform. So any Xapp developer wants to write the application, he will use these services, and not necessarily all of it, but whichever things are required he can use from the framework, and he can write his application. So you can so for example, at the bottom you can see Kubernetes, Xapp Descriptor, and lifecycle management. So any Xapp developer can come. He can just define his Xapp descriptor that will help you to create the Helm chart automatically, and that will help you create the life cycle, and finally it will get deployed to the Kubernetes. It will not do anything. It will just a deployable Xapp. And let's say the developer wants to use the API from the RMR for the communication, or he wants to store some information DB, he can use the SDL. He can do some kind of logging, tracing. So this is all provided by the framework. And then the next layer is a RAN inventory management. So many of RAN is getting connected to RIG. So these informations are available in the inventory system. So they are simplified API to query those NIBs, and you can retrieve all the G node B, E node B, active station, everything you can retrieve it. Similarly, there are respective libraries to handle the other kind of NIBs like UE and for the measurement KPIs. And the earlier version of the OR and SC in Amber release, actually there were the some low-level APIs, you can say primitive APIs, which enables you to communicate with the A1, O1, and E2 interface. And later on in Cherry release, the framework got evolved, and we have introduced very different languages, high-level languages like Go, C++, Python, and well-abstracted API in order to consume those services and APIs, and the development will become more simpler. And also, I would like to mention that Xapp not only talk to the platform. Xapp can interact with each other, and they can consume the information available by different Xapps, and they can perform some intelligent steps. And right hand side, I have just taken the code snippet from the Xapp framework code. So that lists down all the clients which you can use to interact with the RIG platform. For example, RMR client. So that provides you the way to communicate with the RIG platform and another Xapps. SDL to store some information, Rnib, metric, logger, config. So this all kind of services are available, and APIs are defined. So in our session, we will see each use of each of the client and how exactly you can talk to these services, and you can write some real stuff. And yeah, also I would like to mention that the framework code, the Xapp framework code, comes under the Apache license. So let's start with RMR. So that provides the communication to the Xapp. So here in the right hand side, you can see one example. I would like to interact with the A1 mediator in the platform in order to collect available policies instance there. So I will perform some policy query. So in order to do this, first I had to perform one RMR message. So in RMR message, I need to define message type and its a payload. So actually in this particular message, I pass some required JSON as a payload, and finally I will send it over the RMR using the Xapp framework. So you can see the line number 44 there. I'm sending the RMR message xapp.rmr.send message. So Xapp is the instance of Xapp frameworks. So yeah, this will I will use it further in the slides also. So Xapp is an instance of Xapp framework. So once the message is sent over the RMR, so it is actually routed using the routing table. So each Xapp will have its own routing table. So either that will be communicated by the routing manager, or you can have your local routing table. So messages are actually routed using the message type and subscription ID to the destination. So this helps you to make application unaware about the routing. So RMR will take the load of routing the message. So RMR is actually a big topic. So we will just try to understand the idea. We will not go much deep in the RMR. So in this way, we can enable the communication in the Xapp. Now suppose someone wants to store some information in the DB. Let's say there are many RANs are getting connected to the RIG, and we would like to store some information about the RIG, like what is the IP, which E2 terminator is actually handling it, and also which RAN function it supports. So this all kind of information we would like to store in a DB, and we would like to maintain the persistency. So SDL, it provides you one shared data layer to store any information. So in this example, actually STL is using the Redis database currently. So in this current example, I would like to show how you can read the read all the keys, all the key value. In Redis you store actually the key value pair. So in this example, actually I'm trying to retrieve all the available keys in the Redis. So here you can see I'm trying to do xapp.stl.read all keys. So see, you can see that how it's very simple to read the information from STL. So I'm reading all the keys and I'm just trying to print it. So similarly, you can store some information and you can retrieve it. So APIs are available there. Now the next service comes Rnib. So Xapp has one Rnib client. So Rnib is actually built on the top of HTL. So it is a network information base for the radio. So for example, it's a one abstracted API to list on all the gnode bees, connected gnode bees, connected enode bees. So information related to gnode B and enode B can be queried by this another abstraction layer, another simplified API. So for example, here you can see that I'm trying to read the list of all the gnode Bs available in my inventory, and this will get populated when the RAN gets connected to the E2 terminator. So finally it will get populated to our Nib, and you can query it. So here I'm just trying to query the gnode Bs, like xapp.rnib.get list gnode B IDs. So I'll get all the list of the gnode B, and here I'm trying to print all the name of the gnode B. So you will see some more APIs if you go deeper to it. So and the next service is subscription. So like how in Thoralf in his session he was talking about the subscription. So whenever we would like to retrieve some indication message from the RAM from the E2 node, so we have to subscribe to that gnode B. So it will start forwarding the indication messages to us. So in those indication messages, actually we will have the measurement related to RAN or the UE. So yeah, so you can see this big code or this big structure there. We define the RAN identifier, means like here you can see MEID. So that is managed entity ID. So here you will define the gnode B name, and then you have to say that which RAN function you are interested in, and also you will mention where you which Xapp wants to, which endpoint you would like to receive the messages, and also you will define your subscription detail, and also you will define your action, and also you will define your event triggers also. So in event trigger you will say that means in which condition, in which event you would like to receive those messages, and actions like currently report is supported. So you can say that means which action you would like to perform. So yeah, once this message is sent, you will the Xapp will start receiving the indication messages, and you can do some kind of intelligent stuff on the top of these messages. And the next thing comes the alert. So that is actually for your fault management. So in the platform you have the alarm manager who is responsible to manage the alert situation in the cluster. So we can raise some kind of alerts using the Xapp. So for example that you've identified some interfaces down. So now Xapp wants to generate some kind of alert, or some fault situation you identified using the Xapp, and you want to notify to the higher level functions that there's some alert situation in the system. So this can be done using the Xapp also. So here in the example code, in the code snippet, you can see I'm raising one alarm of type alert type 8004 of saying that it's one major issue, saying that I have some network down on X0. So you can see in line number 129, I'm raising the alarm APIs are very simplified to perform this kind of operation. So so once you raise the alert, it will it is pushed to the alarm manager in the platform, and further further it can be collected collected by the Prometheus alert manager, and further it can be processed by any third party system. So it has a well defined interfaces. So there are 4 type of actions you can perform on the alert. So you can raise it, you can clear the alarm, you can re-raise the alarm, and also you can clear all the raised alarms. So these kind of APIs are available to you. So the next thing is metrics. That is for your performance measurement. So every Xapp they want to they will generate some kind of performance metrics. So those can be a kind of a counter, gauge, so this kind of thing, and finally it will be retrieved by the Prometheus. So if you interface it with the Prometheus will collect it, and the systems like the ONAP can again pull it from the Prometheus using the WES agent or it in the form of a WES event. So here you can see in the code how exactly you can define it. First you have to define your counter, and then you have to register this counter, saying that exap.metric.register counter. So here we are just seeing the example related to the counter. So here whenever I receive any rig setup message, so I am trying to increment the counter. So I'm just counting how many rig setup message I have received, and this information will be available to Prometheus to retrieve it, or maybe you can invoke some simple API to retrieve this information on the Xapp. So so in this way you can collect the metrics, and you can communicate to some higher system. So the next concept is configuration. So you can load the configuration, you can read the configuration. Also whenever any configuration changes happens in your configuration file, you can receive the notification. So here in example you can see at line number 100 I'm trying to read configuration from the config file. At line number 100 I'm doing exap.config.getBoolean, and I have provided my my key. So from this key I'll just read the information from the configuration file. So the configuration file can be pushed from the Kubernetes as a config map, or you can define your own configuration file if you're running some local application. So in this way you at the boot time you can just load up some configuration. And let's say there is some changes happens in the configuration, so you do not want to restart your application. So in order to get those notification, you will register your change notification. So in the line number 92 you can see I'm registering one change listener. I have provided one function, and I have just logged it here. Just for example, I just logged it here like config file is changed. So if you write something in the configuration file, if you do something change, so you will get notified here, and then you have to take the certain action according to your changes. So that is for your change management. Now the next thing comes logging. So all developer this is required for the developers. So they want to put some debug logs, they want to put some info logs, warning and error, so that later it will help them to identify the issue, or maybe log the flow of execution. So at the last line you can see in the line number 67, I'm just printing one info log. So I have to say exap.logger.info, then my message. And on the top you can see the 4 APIs are available for different your logging level. So one is debug, info, warning, error. So suppose you want to do some error logging, you have to say exap.logger.error and your message. So you can see how simple is that doing the logging, right? So so now our next thing, the Xapp descriptor. So you can visualize Xapp descriptor as a blueprint of your application. So it holds the information about your Xapp deployment. So till this point, actually, we have written our application. We understood the API. Now we are able to write the code. Now we would like to package our application, and I would like to deploy in the cloud. So in order to do that, we have to define our Xapp descriptor. So this is the metadata which is communicated to Rig platform, and it will create the Helm chart out of it, and finally it will get deployed. So let's go through the Xapp descriptor, what information exactly we have it. So first we have the Xapp metadata that tells you the name of the Xapp and its version. It's the manage object identifier, and then you will see the details about the container. So your descriptor, so finally it will get deployed as a pod, right? And pod will have the container. So this is the information about the container. So you will pull pull the image from registry, and it will have the this name, and also it you have defined the tag. The next thing comes readiness probe. So whenever your application your Xapp is deployed in the Kubernetes, so you will do the liveliness probe. So and the readiness probe. So the so you will do the you will send some, you will invoke the HTTP URLs on your Xapp whenever it comes ready. So Kubernetes will get to know that now your application is ready, and it will invoke this URL. So once so actually readiness probe helps you to register your Xapp. So whenever Xapp comes alive, you will probe some readiness probe, and when the readiness probe is successful, the Xapp will initiate the registration of itself with platform. And now the next thing comes services. So here we are defining various services. So services are Kubernetes construct. So we are defining some HTTP service that is exposed at port number 8080, RMR route. So where we are going to receive the RMR route from the RT manager, and there is a RMR data. So which is exposed at the port number 4560. So there actually the RMR data exchange will happen, message exchange will happen. So at this port. So yeah, so it will be you can see as a services. And the finally we will see the configuration about the Xapp. So here I have just listed the logging related configuration. So I am setting logging level equal to 4. So actually that is a debug logging level. So if you enable the logging level 4, so it's a very specific to Xapp. So Xapp will read this information, and it will read using the config using the configuration, and it will apply onto it. So yeah, in this way your Xapp descriptor is defined. And here we will see end-to-end flow of end-to-end picture of your Xapp descriptor, means how you define your Xapp descriptor, and how that will that finally will get an instance of the Xapp. So yeah, we'll start from the left side. First we will define our Xapp descriptor, and using the Dmx Cli we will onboard our descriptor in Rig platform. So once descriptor is onboarded, now it will be converted into Helm chart at onboarder, and it is pushed to the chart museum. So chart museum will keep all the Helm charts available to us. And yeah, once it is available, now either we can communicate to app manager directly using the REST API, or we can use the Dmx Cli to create an instance. So in a background, it will use the Helm, and it will deploy the instance of it will deploy the Helm chart in provided namespace with provided Helm chart version. So so here you can see, if you don't provide any namespace, by default it will go to the Rig app namespace of your deployment, and it will create an instance. And also in the dark blue color you can see Xapp framework. So that is just like a library that is comes along with your Xapp. So Yeah, this was all idea into an idea about how you will develop the Xapp and how you have to deploy it. Now, I would like to hand over to Naman, so that will so Naman will demonstrate one demo to to visualize this idea of having the descriptor and deploying it to Kubernetes. So yeah, Naman, over to you.
Yeah, hello everyone. Yeah, yeah, so I'll just share. Yeah, so hello everyone. Yeah, thank you so much for the code walkthrough of the Xapp. So let me show you like how to onboard and deploy the Xapp once you have developed the Xapp, like a reference Xapp that we have gone through. And yeah, so let's see and do the hands-on of how you can deploy an Xapp. So yeah, so here we can see that the different pods are running. So you can see there. So this is the RIG platform where we have different pods of RIG platform, RIG infra. So we can see the different A1, so different components like A1 mediator. So we'll be using for this demo like the app manager as well as the Xapp onboarder to onboard and deploy the Xapp. So let's move on. Yeah. So basically, we use for deploying the Xapp, we use Dmx Cli tool, which is so. Let me tell you what is Dmx Cli tool. So it actually has the like it is it provides the commands to deploy Xapps or get the health charts from the Xapp of the Xapps from the onboarder. So here you can see this is the health chart. Also the descriptor which we'll be using for deploying the Hello World Xapp. So we have this reference Xapp, Hello World Xapp in Go language, which we'll be deploying through the onboarder, and it will be deployed in the RIG Xapp namespace. So as we have already seen that this is how we can actually define the containers for the Xapp in the descriptor. Then we can define the liveness probe, and similarly the readiness probe we can define. And so these are basically functionalities which we need to define when we are going to onboard it, the Xapp. And then we have these different services running where we can define like the ports and the configuration details of different services. And then we have this RMR service and policies we can define here of the Xapp, which will be used for interacting with different elements or the RAN function, RAN in the network. And yeah, so that's about the descriptor file. Now we will use the descriptor file to onboard the Xapp using the Dmx Cli. So yeah, so this is how you can use the Dmx Cli. So Dmx Cli has different functionalities like onboard, or once you onboard into the descriptor, the onboarder, you have you can see what all charts are present in the onboarder, and you can select which one to deploy using this Dmx Cli tool that we have instead of using a curl command, which helps you to onboard and deploy Xapp easily. So yeah, so here you can see I've given the config file, which is basically the descriptor, and the schema.json. So this schema.json file actually is used for validating this config or the descriptor file that we are using to onboard the Xapp. Yeah, so here you can see we have onboarded the Xapp, and the status says it's created. So this basically says that you have onboarded the this descriptor, and the descriptor has converted that the onboarder has converted that descriptor into an health chart repo. So here we can actually like request the charts that are available on board on the onboarder. So here you can see we have onboarded this chart, and this chart is available from the onboarder. So basically this curl command is getting all the charts available in the onboarder, which can also be used through DMS CLI. So here you can see we have this chart, all the charts available. So let's go what all is available in the charts. Like basically it creates a help chart where you can like basically see all the values and deployment file. So yeah, so we have basically downloaded this Helm repo that is created, basically Helm chart that is created. And yeah, here you can see this Helm go.tgz. So yeah, let's untar it and see what all contents are there in this folder. So yeah, here you can see we have the charts available, the deployment details, and the services that we have defined in the descriptor. So basically, whatever we have defined in the descriptor, that is converted into the Helm chart for deployment. Yeah. So let's go on and see like what all is there in the values.yaml file. Yeah. And see like so the details that we have provided in the descriptor is translated and can be viewed in this charts. So we have defined the containers, the liveness probe details, and like the different services running. Yeah, so let's use the curl command to actually deploy the Xapp. So here we can use the app manager to deploy the Xapp, or we can use the DMS CLI also. So you can see here we have defined the Xapp name here as a hello world Xapp. You can like if you are running a different instance, you can give it another name, or if you have a different Helm version, so you can define the Helm version also here itself. Let's deploy the Xapp now. So basically this Xapp, when it is deployed, so it will be running in the Xapp namespace. And once it is deployed, you can use it for different purposes. So it will basically have the business logic. So once it is running, it actually so the case can be like you are taking the metrics, collecting the metrics from the RAN. So that will be deployed. So yeah, here you can see we have deployed the Xapp successfully. It's running. So let's see what all services are running, and then later we can. Yeah, so here you can see that we have this Hello Go HTTP service running and RMR. So these are different services running for different functions that we have developed in the Xapp. And then here using this like curl command from the app manager. So this gives the functionality that we can see what all instances are running of this Xapp. So since we have only deployed a single instance of the Xapp, you can see we have this service running, and basically different RMR messages that is enabled in the Xapp. So as Subhash already like rightly said, that we can use subscription to basically get some controls over the RAN, and then we have even policy towards the northbound side of the RIC, and then we have this health checkup, which will help in basically to see that if the Xapp is running or not. So yes, moving on, let's see that it's successfully running. The Xapp is successfully running. Um, so uh, let's get basically the pod that is running. Here we can see the pod, and let's see the logs from it. So yeah, just So here you can see that there are different services like subscription manager, E2 manager, A1 mediator. So all these are running, which we have coded, and yeah, so we have successfully deployed the Xapp. Yeah, that brings to the end of the demo. So if for the details of this, like how you can deploy an Xapp and to find the code of the Xapp reference Xapp that we have written, basically the Hello World Go app. You can uh, uh, get the link. So you can see this link which we'll put in the description or in the chat box also. Yeah. So like now I'll be passing on to Subhash for uh, like the further.
Thank you, Naman, for helping us to understand and see the real things on a screen. That means how we deploy the Xapp. So yeah, that was very interesting demo. So yeah, guys, and also I'll encourage everyone to see the code that is available in the Gerrit. So that is a open source platform. So you can visit there, and also you can find the details in the wiki pages. So we have listed it here. So yeah, just before winding up, I'll just quickly go through the what Samsung is exactly doing in the Oran SC. So we are contributed in the previous releases of the Oran SC for the A1 AI interface. So that actually brings that enables the Xapp to consume the enrichment information. So that in the further it will help to bring some AI ML kind of stuff in the platform and Xapp. And also we are working on the enhancement of the Xapp framework and near rig platform. So we have done some good enhancement in the platform also. And also we are developing working on the HWGo and HWPython as a reference Xapp, so which any developer can we can go through and understand how the development happens for the Xapp. So yeah, HWGo is the example which we followed. And also one important thing we are also working on in the support of E2AP version 1.1. So in last release we did not implement it, only we have submitted the design documentation. So in the further release you will see the implementation of E2AP in a platform. So this is some high level view of how Samsung is contributed to Oran SC. And now I would like to open the stage for question and answer. And yeah, you can ask any question we can take. Yep.
Thank you, Subhash and Naman. That was really a nice walkthrough the Xapp and very easy way to explain right from the beginning, those who even doesn't know what is an Xapp. So coming to the questions, we have two questions. We are almost at the end of the event. We are actually 1 minute ahead, exceeded actually. So the first question is for Thoralf. The question is, how far are we seeing the near RT rig for the commercial network? Is it ready or it is yet to ready, and how much time will it take?
Well, it's an open source project, so you need, in order to sell it, you need to make something out of it. And clearly, as an open source project, it cannot be used yet. However, now I do marketing, but on Nokia side, we do make a product out of the source code. There are lots of additions, changes we do, and we already promote that to operators.
Thank you, Thoralf. And I think that there was one more question, but you have answered in the chat already.
Yeah, I can maybe, I see the question. So the question was about the rig inventory management.
Right.
Is it aware in advance of which GNODs there are or which E2 nodes? And it is actually not. It's a complicated topic. So originally it was 2 years ago, but then we changed on the specification side the direction of how the GNOD connects. And it actually initiates the connection. And this means that the rig doesn't have to be aware anymore which E2 nodes there are. Right now, there is no access control, so any GNOB can actually create a E2 connection to the rig. Eventually, we will have on the open source side also to have some control over which GNOBs can connect and which ones can't. And it goes further then also into scalability and failover. How do we manage GNOBs high availability, the E2 connection high availability?
Thank you. Thank you once again, Thoralf. It was really great to know the ORAN, ORAN-SC, the differences, the architecture of ORAN-SC, and the way you explain the real-time, near real-time, and the other modules. It was very easy to understand. I'm sure people on the call must have learned a lot. Thank you, Subhash and Aman, once again. With this, we come to end of the event. I know that people who were there in the morning, some of them have left, and there were few who joined us for specifically for the Xapp. Behalf of all, I would like to thank everyone to be with us for almost for 5.5 hours. Thank you to all speakers and volunteers who have helped to make this event successful. Have a great weekend. Stay safe. Take care. Bye-bye.
Thank you, everyone.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.